Hi everyone, welcome again to another video of SAT Math. Today our topic will be quadratic functions. It's been a while since I uploaded because this is literally the fourth time I record this video. I keep having technical issues like my camera connecting as a microphone. But anyways, so basically Vigor Group 1 requested a video on advanced math graphs, equations, so nonlinear equations like exponential graphs, quadratic graphs, and fundamental rules, and using desmos. So that's what today I'm going to go over the quadratic functions more in depth. And then in the coming days, I'll make another video about exponential graphs. So I do have a video about the focus skill, non-linear functions, and also one I think it was nonlinear inequalities and nonlinear system of equations. But anyway, so those are less in depth. Those just go over broad and give examples. Today I'm going to do a lot more in depth about quadratic functions. I'm going to try to explain everything that's related, everything you need to know about them. Let's get started. So the different equation forms, I'm going to start with that. So before we get started into going into depth with all the formulas and techniques, it's important to note the forms that you will encounter. How is it going to look like on the SAT? And in general also. So the standard form is the most common one, and it's the most useful one. You can get the most things out of it. So what does it look like? It looks like ax squared plus bx plus c, where a, b, and c are constants. And so first thing I'm going to show you guys all of them, then I'm going to go into depth in all of them. So vertex is then a times x minus h squared plus k, and a, h, and k are constants here. So I'm going to go over what the constants mean later on. Factor form looks like a times x minus r1 times x minus r2, and r1, r2, and a are both constants. So, yeah. And I'm going to go over what the constants are and what they do later on. But basically, I just want you guys to notice before I go into depth on each one. Each one of these has a in the beginning, is being multiplied in the beginning. So what does the a do? Basically, the a determines how wide or narrow the quadratic is. So if it opens up, you're going to sorry. So I'm jumping. Basically, the closer it gets to 0, the more wide it gets. So if you have 1/2 compared to 1, 1/2 is closer to 0, so it's going to be more wide. And I'm sorry if the audio isn't good because they're doing some work. But yeah, so the closer it is to 0, the a value, the more wider the graph is. So 1/4 is wider than 1/2, which is wider than 1, which is wider than 5. And the other thing you need to know that is very important, it's very important, is basically, if a is greater than 0, that means the quadratic opens up. What does that mean? Basically, it opens like this. It opens up. And then if a is less than 0, it opens down. Opens down. And what does that look like? It looks like this. Okay. So that is it for this. Let's move on to in more depth standard form. So standard form, it's the one with the most things you can get out of. And although most of these things you will be able to find using desmos, sometimes there's going to be some questions where you basically can't use desmos because there's too many variables on the. I mean, you could technically there are ways to use desmos, but it's going to be more preferable to use paper and pencil because there's going to be a lot of variables. Maybe a and b aren't going to be defined. So it's going to be a good way to solve it would be to know all of these things. So first thing is the x value of the vertex is something that you can derive from the standard form. So first of all, what is the vertex? So let me just show you guys up here. The vertex is basically the point where it goes from increasing to decreasing, and then and vice versa, decreasing to increasing. So it's basically right here. It's the point where right here it's decreasing and then it's increasing. And when it opens up, it's going to be the minimum of the graph. On the other hand, if it opens down like that, the vertex will be the maximum. And that is a very important part of quadratics. So how can we get the x value of the vertex from standard and the whole overall coordinate as well? So first of all, the x value of the vertex from standard form can be found using negative b, the formula negative b over 2a. So what are these letters? If you guys remember these, there's a, b, and c. So if you take negative b divided by 2a, so the coefficient of x divided by 2 times the coefficient of x squared, you will get the x value specifically of the vertex, and then you have to plug in the x value that you get back into the equation, and then from that you can get the y value of the vertex. So that is good to know. The second thing is product slash sum of roots. This is honestly not that important. I haven't really used it that much in my experience. Maybe like one time. It could still help you with like solving for some variables or something like that. But overall, it's not the most important thing to know. Like, it's maybe from all of these, it's the least important thing. Like, I didn't even know about it until like a month ago, and I did not do bad. Like, I didn't even like I didn't need it in the questions, but it could be useful. So I'm just going to, again, it's very easy to memorize. So, the product is equal to C over A. Oh, wait, sorry. I'm just going to, just in case you guys don't know, what is the roots? So let me just take a moment to explain this. Basically, when you have the quadratic graph, it's going to most of the times or sometimes intercept the x-axis. So right, these points where y is equal to 0. So these points are like very important, and they have different names used, and there's actually 4 of them that I think show up on the SAT and in algebra in general. So what are those? Basically, there's roots, like I just showed, like the product slash sum of roots. There's roots, there's just x-intercepts, it intercepts the x-axis, so that kind of makes sense. And then there's zeros, which comes from because y is equal to 0 at those points. And then the last one is solutions, because they're considered the solutions to the quadratic graph. Oh yeah, so that's just good to know. Zeros, x-intercept, roots, zeros, x-intercept, and solution. It's good to know. It's good to be able to recognize what that means. If you see this, you know, okay, I'm thinking of when does it intercept the x-axis. So the product slash sum of roots the product is going to be equal to C over A. Again, we're talking about these constants. So the product is going to be equal to C over A. The sum is very similar to the x value of the vertex, except there's no 2, so it's just going to be negative B over A. There's no 2A. So these are just good to memorize, but they're not important. But it's not going to harm you. The next thing is a quadratic formula, which basically is a way to find the roots. But actually, yeah, I'm going to go over factoring first. So I'm going to go over factoring. So factoring, if you already know this and you don't want to watch an explanation, you can just skip a couple, like maybe 1 or 2 minutes. But I'm just going to explain it. So basically, there's 2 types of quadratic of factoring. That there's 2 basic techniques depending on what you get. So sometimes there's actually 3 techniques, because quadratic formula is the 3rd. But in factoring, there's 2 that I know of. So basically, all it depends on which one you use is based on the a value, the coefficient of the x squared. So if the coefficient of x squared is equal to 1, it makes things a lot easier. So that's going to be my first example. So right here, you don't see it because it's technically times 1, but there's a coefficient of 1 right here. So 1 times x squared plus, I'm just going to do a quick example. Let's say 6x plus 8. That's a good example. Basically, for when there's no coefficient, what you do is you just think what multiplies to make C value. So that's the constant. But what 2 numbers multiply to make the C value. But those 2 numbers also at the same time add to make the B value, the coefficient of x. So in this example, you just keep guessing and checking. Okay, 8 times 1 multiplies to make 8. There's no way, like using negatives or positive, like maybe 8 minus 1 or negative 1 plus 8, something like that. There's no way I can get 6, so that's not an option. Another option is, let's say 4 and 2. If I do 4 times 2, I can get 8. If I do 4 plus 2, I can get 6. Then I know, okay, that is it. And then I literally I do parentheses, plus, and then x plus. And then I just put the numbers that I just got. X plus 2, x plus 4. This is it. That's it factored. So I'm not going to go over this as much right now, but that is actually the factor form. So factoring is the way to go from standard to factor form. Factor form is basically the least common form that's going to show up on the SAT. You won't need to know how to factor, but factored form is not going to be used as much. So you saw that was very easy. But what happens if there is a what's it called? What happens if there is a coefficient? So let's say it was 2x squared plus 6x, same thing, and instead of plus I'm going to make it minus 8 so that it works out better. So this one, now there's a coefficient in front of the x, so when instead of saying what multiplies to make c but then adds to make b, you're actually going to have to say what multiplies to make a times c, so what multiplies to make ac and adds to make 6. So in this case we're looking for what multiplies to make negative 16 and then adds to make 6. So what would that be? You just have to keep guessing. So something that multiplies to make negative 16. 4 and 4, that's never going to add up to 6. 8 and 16 and 1, that's never going to add up to 6. Then you 8 and 2, that 8 times 2, that's going to add to 10. What about if I did negative 8, or what if I did 8 and negative 2? 8 times negative 2 is negative 16. 8 minus 2 is 6. So you also have to not only play around with the factors, you also have to play around with the negatives and positives. But anyways, so 2x squared plus 6x minus 8. So then you wouldn't automatically go to factor form. What you would do is you actually would expand the 6x. So 2x squared plus your two numbers. We said 8x minus 2x minus 8. From there, you are actually going to group the first two terms and group the second two terms. It actually doesn't matter which order you put these ones in. It doesn't matter. I just wanted to make, and it's still added. You group them, but just remember they're still being added. There's a plus sign there. There's supposed to be a plus sign there, like that. Okay. So then from there, you're going to factor out the greatest common term. It's not greatest common factor, technically. Yeah, it's the greatest common term. So you look at this one, 2x squared and 8x. What's the biggest thing that I can take out, including numbers and variables? So the biggest number I can take out is 2. Both of them are divisible by 2. So I'm just going to take out a 2. Just give me a minute. Let me just make more space. Okay, this is not fun. Okay. Okay, so then I'm going to factor out a 2, and then this one's 8x, this one's x squared. So I can also factor out an x, which is very good. So now I have 2x, and then the inside, I'm going to divide each term by the thing I took out. So 2x squared divided by 2x, I get x. 8x divided by 2x, I get 4. Okay, so that's good. We're finished with the first one. Let's move on to the second one. For the second one, I have negative 2x minus 8, so I can't factor out any variables, any x, because 8 doesn't have x. But I can factor out negative 2, and you always want to try to make the first term you need to make the first term positive for it to work. And so then basically, what do we get? We get, if we factor out negative 2, so minus 2, I get x plus 4. And how will you know that you did this right? If both inside terms are equal, that means you did it right. If they're not equal, if they're not the same, like right here I got x plus 4, x plus 4. If I got, let's say, x plus 8 and x plus 4, I know that I made a mistake, which I have to go back and see what I did wrong. So then from there, you're going to take this term that you factor out, this term you factor out, and then add them. I'm going to get 2x minus 2, and I'm going to group those. And then if you did this right, these should be the same, and you're just going to take down one of them, or bring down one of them. So you get x plus 4. And that is how you would factor with a coefficient that is not equal to 1. Also another way would be to basically you could, if there's they're all divisible by something, you could technically just, like, for this one you could have just divided each one by 2 and you would have been left with x squared plus 3x minus 4, which is easier to work with. Actually, x squared plus 3x minus 4. So 4 negative. Oh yeah. But anyways, so that is how you would do it with factoring. But what if you use desmos? So as I said, desmos is useful, but it's not always necessary. So just give me a minute to open desmos. So using desmos, what you would do, you would basically just sorry, is it? Wait, let me just make it. Okay, that's better. Okay, so basically using desmos, what were our examples? We have these two examples. It took us like some time to solve them, to find the x-intercepts. So if you literally just type them into desmos, if you want to do that, you literally just type it in. It's going to highlight them with these dots for you. You get x equals -2, x equals -4, which is what these mean. I know it says +2, but basically what you have to do is you have to actually set each one equal to 0. So x plus 2, set it equal to 0, and then you get x equals -2, and then x plus 4, you set it equal to 0, you get x equals -4, which is what shows up on the graph. And then you have to also plug in, you can do the same thing for the other one. So plus 6x and then -8, and then you get, you should have gotten x equals -4 and then x equals 1, which is what we got. So that is how you would use desmos. It's a lot faster when you can use it. So you should always try to make sure that you can utilize desmos to its max. So let's go back to the quadratic formula. So the quadratic formula is basically, sometimes there's going to be times where, like, okay, I want to find what number multiplies to make a times c adds to make b. It's not going to exist. I can't find anything. So what I would have to do is use -b plus or minus the square root of b squared minus 4ac all divided by 2 times a. So this is a lot to memorize maybe for you. So basically the questions that require the quadratic formula are, this is basically how they are. It's going to be like, give you an example, which of the following is a solution to the following equation. It's going to be one of them where you can't factor. So then all the answer, maybe it's going to be like 7 plus square root 11. All the answer options are going to look something like that. Or maybe like 7 minus square root 11, you know? Or 22, something like that. It's going to look like this in the form of the quadratic formula. So the ways to solve this would either to be just directly use the quadratic formula to get exactly the solution. The other way would be to graph it, but then you would actually get your answer in a decimal. So then you would have to actually go open Desmos and then put every answer option into Desmos until you see one with the decimal that aligns with the x-intercept that you get. Because Desmos on the graph, it's not going to give you like 7 plus square root 11. It's going to give you maybe like 10.31 something, and something like that. So you based on what you prefer, you get to choose how you want to solve this, and based on that, do you need to know the quadratic formula or do you not? The next one is completing the square. Basically, that is how you go from vertex to standard. That is how you go from standard form to vertex form. I'm going to be honest with you guys, I've never actually used that on the SAT. I've never encountered anything that required me to complete the square. And again, I'm just completing the square, basically. Yeah, so completing the square, to go from standard to vertex, it's never going to be necessary. So I'm actually going to, I'll go over it briefly if you guys want to skip over it, because it's really not necessary. Let's use the same example we had here, x squared plus 6x plus 8. So let me just make some space. Okay. So I'm actually going to erase that. So let's erase that. Basically, to complete the square. Okay. So, completing the square, how does it work? Where's my cursor? How does completing the square work? Okay, so basically, let's use our same example. X squared plus 6x plus, what is it? Plus 8, and it's equal to y. I didn't write that the first time, but it is equal to y. Equal to y. So what you do basically is, first thing what are we trying to do? We're trying to get x minus something or x plus something squared. So how do you do that? First thing, you're going to get rid of the constant. So we're just going to take the other side. So you get x squared plus 6x equals y minus 8. From there, you want to get a perfect square so that you can basically simplify this from like x squared plus 6x plus something into like x plus something squared. So how do you do that? This is 6x. Basically what you do, you take the b value. So for us, the b value is 6. So you take the b value, so b over 2 squared, divided by 2 and square it, then you will get our new term. So what does that look like? Like, I'm going to do x squared plus 6x. 6 divided by 2 is 3, 3 squared is 9, so I'm actually going to add 9 to this side, and whatever I do to this side, that's the most common mistake with completing the square. You forget to add the thing you add on this side to the other side, so -8 plus 9, I'm left with y plus 1. And so then from there, x squared plus 6x plus 9. The whole point of this is to get a perfect square. So what's the perfect square? This actually simplifies to x plus 3 squared. So basically, b over 2 is how it's going to work. And then squared, and that is equal to y plus 1. And then I'm just going to subtract 1 from both sides. X plus 3 squared minus 1 is equal to y. And that's how you go from standard to vertex. Again, it's not really necessary. You could, if you really want to, for some reason, change to vertex. If you have the equation, like we had here, just x squared plus 6x plus 8, you can graph it. And that is what I'm going to explain right now. So, okay, I'm sorry, okay. I'll just explain it real quick right now. The vertex form is basically negative h plus k. So the vertex is h comma k. H comma k, and pay attention, there's a negative here. So if it's negative, it's actually positive. If it's positive, it's actually negative. But then, so if the vertex is h comma k, you can actually just graph it, look at the vertex. The vertex is negative 3 comma negative 1. And so then that's what you would type. So x minus 3 squared, and then minus 1 equals y. So that's a lot faster if you can just graph it. And that's it. Oh, sorry, I forgot to go over the discriminant. So that's the last important thing for the standard form. So what is a discriminant? The discriminant is basically it's the thing under the radical in the quadratic formula. B squared minus 4ac. So what is this going to tell us? This is actually, you need to know this one. Unless, I mean, there's other ways, but it's very good to just know it. So b squared minus 4ac is what it is. And what does it tell us? Basically, it tells us the number of solutions. So how can we know? So basically, when you solve for b squared minus 4ac, if it's greater than 0, so if it's positive, you have 2 solutions. If it's equal to 0, you have 1 solution. So what is this going to look like this? A solution, again, it's like the x-intercept, so it's going to intersect twice. Equals 0, there's going to be 1 solution, so it's going to be like 1 point exactly. Okay, I'm not showing that actually. Okay, so it's going to look like this. So the vertex is going to be the only point that touches the x-intercept. Then if it's less than 0, it's going to be 0 solutions. So what's that going to be like? It's going to be basically above or under, depends on how it opens up or down the x-axis. So that is it for the discriminant. Basically, a question is going to be like, it's going to be like x squared plus bx plus 10 has only 0 solutions. Which of these is a possible value of b? So then the way would be to either set this equal to greater than 0. I think I said 2 solutions. So if it has 2 solutions, I'm going to set it equal to greater than 0, and then I'm going to solve. That is one way. The other way is to use desmos. Basically what you would do, so we're saying that it has 2 solutions. So let's say it's asking for the minimum value for it to have. Which of these values is, let's say it says, which of these values is a possible value of b. So what I'm going to do is I'm actually just going to type it in exactly how it is, with the b, with the variable. And it's going to tell you, wait, I don't know what b is, so you can actually add a slider. So then you're trying to find the minimum value of b, which it can have 2 solutions. Or in this case, it's the minimum. So basically, how would this look? You just keep playing around with this until you see that, okay, at 6.4, I see that I finally have 2 values. So you could keep going more specific, but on the SAT, it's most likely going to be an integer. So you can just say any number greater, like when you look at the answer options, it depends how specific you want it. Most likely, what I've seen, they're always going to be integers, like let's say 7, negative 12, 13, something like that. So you're going to need one of the options to be greater than 6.4, let's say. Yeah, so greater than 6.4. And then that's going to be maybe like 7 or 8, and there's only going to be one answer option. So you could either learn the discriminant or just learn how to use the slider on desmos. So I know that was a lot to take in, but that is it for what you need to know for standard form. Vertex and factored are very simple, maybe like a minute of explanation. Like I said, vertex form, the only point of it is the vertex. That's the only thing that's really useful. Sorry. For standard form, I forgot to say, C is the y-intercept. That's another good thing to know. So the y-intercept, when it intersects the y-axis, that is actually C. Anyways, so the vertex h comma k, so and this the only point of the vertex form is it technically tells you A if it opens up or down, but all of them give you that. And then the vertex h comma k, and just make sure you realize that it's x minus h. So if it's like x minus 1 squared plus 5, this actually the vertex is going to be at 1 comma 5, not negative 1 comma 5. And then to go to standard, it's going to pop up a couple, maybe like one time, maybe. You need to like maybe convert vertex to standard. If when you're asked to do that, if you're asked to do that, basically just simplify everything. Your standard form is basically the most simplified form. You basically multiply everything, you add, you combine all like terms, you do everything. So to go from vertex to standard, you're just going to like this like apply the exponent, multiply a, and then combine like terms. And that's basically it for vertex. Factored form, same. Factored form is basically x minus r1, x minus r2. So r1 is one of the roots, r2 is another root, and also notice that it's minus and minus. That is also the only point of factored. It gives you the roots, and most of the times you're going to be going from standard to vertex like we did when I explained factoring. You're going to go from standard to factored form to be able to see the vertex to be able to see the x-intercepts without having to graph or using the quadratic formula. If you were to go from factored to standard, same thing. Just multiply everything and then combine like terms to simplify it to the best of your ability. And that is really it. So I'm just going to show one example just to show you guys how desmos is going to be is basically the best way to solve this. So this one gives us a quadratic function, h is defined, shown. I can see that this is in vertex form. It's in vertex form right now. And so it says y equals h of x, so it's the same thing, the line, intersect the x-axis at points 0, 0, and t, 0, where t is a constant. What is the value of t? So if I wanted to solve this on paper and pencil, what would I have to do? I would have to go from vertex to standard form, and from there I would either have to factor, and most likely it's going to be factor because you see there's not a lot, like all the answers are like integers. So you could either factor or you could use a quadratic formula depending on your preference. But that's a lot of work. So the best way to do it was to just open desmos. Okay, I thought I wasn't recording. Okay, is to just open desmos and then open desmos and then just type it in. You don't even have to change it to standard or anything because desmos is just gonna graph it the same way. And then minus 32. And then you look, okay, there's 0, 0. The other point is 8, 0. So that means t is equal to 8. I just solved that in like 10 to 15 seconds using desmos. If I wanted to go from standard and then if I wanted to go from vertex to standard form, and from there, I want to go from, I have to either use a quadratic formula or factor. That's going to take like maybe 2 minutes, and which is a lot of time on the SAT. And also, it is prone to human error. Unlike desmos, the only error would be to type it wrong, which would be, or misclick, which would be sad if you did that. But yeah, so that's just it. Just a brief example of how it would work. So I'm only going to over one example today. If you guys want, like I said, I have already 2 videos about nonlinear equations. If you guys want to go back and watch those, or like skip to the end, I'm going to have, there's 10 practice problems, like 5 in each one. You can just like filter out, find the ones about quadratics and try those. And also you can just go to the SAT question bank, like put the filter, nonlinear functions, find the quadratic functions, and Khan Academy. And that is it for quadratic functions. That is it in depth and everything you need to know about them to ace the SAT. So if you have any questions or comments, let me know in the comments. And if you have any video you want me to make like this, just let me know in the comments. I'll try to make it as soon as possible. I will not take like a week like this time. I was just very busy. And the last thing is yeah, I'll have a video about exponential graphs. It's gonna be a lot shorter than this because exponential doesn't have that many things. It's going to be a lot shorter, and I'll try to upload it in the coming days. Thank you guys for watching, and bye.